Far out in the vast darkness of space, among countless stars and distant worlds, there lies a remarkable blue sphere, our home. From a distance, Earth might look like a tiny dot floating in nothingness. But that unassuming orb is nothing short of miraculous. Here, on this planet, life flourishes in countless forms, from the tiniest microbe deep in ocean trenches to giant redwoods, from desert scorpions to humans crafting stories and songs. What makes Earth the stage for all this wonder, for life itself, in an otherwise hostile universe? The answer lies not in a single trait, but in a finely tuned tapestry of conditions, woven together over billions of years, each thread vital to the whole. Imagine for a moment a planet orbiting a star. If that planet were slightly closer to the star, searing heat would bake its surface, water would vaporize, leaving a barren, suffocating rock. Move it slightly farther away, and frigid cold would freeze every drop of moisture, locking away any hope for living chemistry. But Earth sits in just the right spot. Its distance from the Sun sits within what scientists call the habitable zone, a Goldilocks region where sunlight is gentle enough, and warmth is balanced so that water can exist as a liquid, not all steam, not all ice. Because of this delicate balance, oceans, lakes, and rivers lace across the planet, covering roughly 71% of its surface. Those vast seas hold more than just beauty, they are the cradle of life, the medium in which molecules dance and chemistry sparks into biology. Water is not just a backdrop. It is a universal solvent, dissolving nutrients, carrying heat, enabling necessary chemical reactions inside cells, and forming oceans, clouds, rain, the heartbeat of Earth's water cycle. Without liquid water, cells could not form, chemical reactions that power life would be impossible, and the drama of seasons, weather, and climate would not exist. Earth's abundant water makes it unique. No other known planet hosts stable, expansive bodies of liquid water on its surface. But water alone does not guarantee life. Surrounding the planet is an atmosphere, a delicate, life-supporting veil. Composed primarily of nitrogen and oxygen, with traces of other gases, this envelope of air does far more than let us breathe. It acts as a thermal blanket, holding in warmth, smoothing out temperature extremes between day and night, supporting weather, clouds, and rain that sustain ecosystems. It also protects living organisms from harmful solar radiation, from damaging ultraviolet rays to deadly cosmic showers. Without this protective atmosphere, living beings on the surface would be battered and burned, and the planet's climate would swing wildly, too hostile for sustained life. Delve even deeper, beneath the oceans and soil, and you find another crucial layer of protection, Earth's magnetic field. Around 3.5 billion years ago, perhaps earlier, the molten iron in Earth's outer core began to swirl, generating electric currents that birthed a magnetic field. This magnetic field stretches far into space, forming a magnetosphere, an invisible shield that deflects charged particles from the sun, the solar wind, and cosmic radiation that would otherwise relentlessly bombard the planet. Without this shield, solar wind would slowly strip away the atmosphere and even evaporate the oceans. Earth's magnetic field is more than convenience, it's a lifeline. Inside Earth, heat still churns. From the secret depths of the core, internal heat flows outward through the mantle, powering geological processes like volcanism and the slow dance of plate tectonics. This shifting of enormous crustal plates is not a destructive force alone, it is the engine of renewal. Through earthquakes, volcanic eruptions, and the shifting continents, vital nutrients and minerals are recycled from the planet's deep interior to its surface. Volcanoes breathe life into the land by renewing soil, releasing gases that help regulate climate, and maintaining a balance of carbon dioxide and other gases in the atmosphere. Plate tectonics, rare in the known universe, gives Earth a dynamic, ever-changing surface, sustaining the cycles that keep life robust over eons. The presence of plate tectonics also helps regulate Earth's climate over geological timescales. Rocks weather, minerals shift, carbon locked away in ancient life buried by tectonic subduction is recycled, atmospheric greenhouse gases fluctuate just enough to keep the planet within a livable range. If Earth lacked this internal churn, if it were static and dead, its climate might drift toward extremes, the atmosphere become unstable, and life might struggle to adapt or even begin. Many planets might exist, but very few, perhaps none that we know of, have such geological vitality. Yet Earth offers more intricacies that weave the web of habitability. Its tilt and rotation, moderated by the presence of a large moon, produce cycles of day and night, seasons, tides, rhythms that shape ecological niches and influence evolution. The gentle ebb and flow of tides churn coastal waters, distributing nutrients and allowing marine life to adapt to changing environments. Seasonal shifts provide opportunities for different life forms to thrive at different times, driving genetic diversity and complexity. The large moon stabilizes Earth's tilt, preventing extreme variations that might cause severe climate swings, a subtle but indispensable role in life's long-term persistence. Earth's chemical richness also plays a defining role. The right mix of carbon, nitrogen, oxygen, hydrogen, the building blocks of organic molecules, is available in abundance. Carbon cycles between living organisms, atmosphere, oceans, and the Earth's crust through weathering, decay, volcanic outgassing, and subduction. This cycling ensures that carbon is neither too scarce nor so abundant as to cause runaway greenhouse heating. Oxygen, replenished by photosynthetic organisms, fills the atmosphere to a level that supports complex life. Nitrogen and other essential elements stay in balance. This delicate chemical equilibrium is fundamental to biochemistry, the complex interactions that enable cells to function, replicate, evolve. Time itself is another essential ingredient. Earth is about 4.5 billion years old, and for most of that time, internal and external processes have worked in harmony to maintain stability. Water persisted, the atmosphere remained breathable, the magnetic field shielded life, tectonic plates moved, climate stayed within habitable bounds. This long stretch of time allowed life to emerge, adapt, diversify, evolve complexity, from simple single-celled organisms to creatures that build cities, tell stories, gaze at stars, and wonder about their own existence. Consider all the likely missteps. If Earth had formed a bit closer to the Sun, it might have become a scorched Venus-like oven. If it had formed slightly farther, perhaps a frozen Mars-like wasteland. If water had been more abundant, the planet could have been entirely deep ocean, no land, no evolution of land plants or animals. If the atmosphere were thinner, or composition different, surface radiation could sterilize emerging cells. If Earth lacked a magnetic field, solar wind could have stripped away air and water. If plate tectonics didn't operate, atmospheric gases and minerals wouldn't recycle, climate would drift toward extremes, geology remains stagnant. If the moon didn't stabilize Earth's tilt, climate may swing wildly, preventing stable ecosystems. Each of these factors alone could doom a planet. That Earth has, by sheer cosmic luck, by deep time, by delicate balance, escaped all those fates is extraordinary. We might search the night sky for other worlds, hoping to find another Earth, another cradle for life. And although astronomers are discovering thousands of exoplanets, even those orbiting in habitable zones, none so far offer the full suite of interconnected conditions Earth enjoys. Liquid water might be possible, but maybe there's no strong magnetic field, or the planet's crust is dead and unmoving, maybe its orbit is erratic, or its atmosphere poison. Life, at least life as we know it, might never get a chance. Our planet is more than a rock circling a star. It is a finely tuned orchestra of physics, chemistry, geology, and time, performing a symphony that births and sustains life. Every breath we take, every drop of water we sip, every tree we look at, every creature we share the world with, all exist because Earth is exactly what it is. Perfect, but fragile in its perfection. If we pause for a moment and appreciate this delicate miracle, we realize that Earth is not something we own, but something we inhabit, something to cherish, protect, and respect. For there may be other worlds out there, perhaps even some similar to ours, but none will be quite like Earth unless the same rare harmony plays out. And until we find such a world, this blue planet remains our only home. The miracle of Earth is not just that it supports life, it supports wonder. It holds the stories of billions of creatures, the memory of eons, the promise of possibilities. As you watch this video, imagine the silent dance below your feet, molten iron swirling deep beneath the crust, currents of air above your head, water cycles turning unseen, all conspiring to give you a breath of life. Imagine continents drifting slowly, volcanoes renewing soil, oceans teeming with hidden worlds, the sun rising and setting. Imagine the odds, cosmic, improbable, that conspired to make this world just right. Life is not just a biological phenomenon. On Earth, it is a statement that in the cold, dark void of space, somewhere, by chance, by fate, by the improbable, a planet became alive. And that planet is ours. Let us remember, with humility and awe, that our home is unique, at least until proven otherwise. And in the vastness of the cosmos, perhaps nowhere else will we find life quite like here. For now, Earth, fragile, exquisite, alive, holds the secret. And we, its inhabitants, carry the legacy.